Hey everyone, this is part two of parallels and transversal figure problems. If you haven't watched the first video or completed the first module, please make sure you complete that before moving on to this video. We're going to be using the same document that we used in the last video, so as you can see, these are the previous examples we did in the last video. We're now going to go on to page 4. I'm going to do 3 examples in this video, have you try one, and hopefully you're going to feel a little more comfortable doing these types of problems. Sorry for the quality of the actually came out to be a little better than I expected. Okay. So in the last video, I really emphasized labeling your drawing, making sure that you mark everything on the drawing and use something to denote parallel. I was recommending highlighter. You ultimately can do whatever you want with that, but I like using the highlighter. It just makes things a little bit easier in the long run. Okay. ABH. So you just really have to kind of watch yourself. BCK when you're doing this to make sure you're labeling everything properly. KHN, that is going to put me down here, 8x plus 5. So ultimately, like I said in the last video, you always have to try to figure out what the relationships are. Again, here is a common error that I see among students. They'll look at these two angles right away and say, boom, they're corresponding angles, set them equal, and you solve for x, and you think you're done. Here's the problem. In order for corresponding angles to be congruent or equal to each other, they must be contained onto the parallel line. Well, you might say, well, they are in a parallel line. No, that's the transversal. The transversal is what connects the two angles together, the 7x and the 8x. The lines that are supposed to be parallel would be the EB and the FC. And since they are not, we cannot, there we go, let me undo it. We cannot say those are equal. The relationship ultimately that I need to look at is this one versus this one. And not directly, there's no direct name to correspond those to each other. Because they're on alternate sides, one's on the inside, one on the outside. We don't really have a name for that. So the thing that I can do to try to figure this out is I know that this angle is the same as this one because they are corresponding angles. And again, I can do that. They're on the parallel lines. 7x plus 28. This is your transversal BH, and then here's your other one. Okay, once we've done that, we know these are a linear pair. That creates our equation. Once you have your equation, you're ready to rock and roll. So let's go ahead and do a little algebra. So that's going to be 15x, 28. That's going to give me 33, I believe. That's going to equal 180. We then are going to keep doing our algebra here. So 15x and 180 minus 33 gives me 147. Divide that up by 15. We're going to get something kind of strange for this. Get 9.8. That's okay. We can still try to work through it. FCD, that's what we need to find here. So let's go ahead and switch to the green pen so you can see. FCD is this angle right here, which is a vertical angle with the 8x minus 13. I'm going to plug that 9.8, multiply it by 8. I'm going to subtract 13 from it, and I'm going to get 65.4. So I can go straight to saying that. 65.4 degrees. Now, again, as I mentioned in the last video, you always want to take that decimal and multiply it by 60 so we can write it in degrees, minutes, and seconds. So 65 degrees and 24 minutes. That is going to be my final answer for our first question. And we're going to move on to our second example now. AE is parallel to DC, so we're going to use that and that. I'm going to use a different highlighter color to do ED and AC. Awesome. Oops, that didn't work. Okay, label. EDC, 135. EAB, that's down here, that's 4x. And EBA is 3x. Okay, right away, we should see an easier relationship versus maybe the 4x. These two right here, they're a linear pair. Linear pair means they add up to 180. So here is our setup. And go ahead and solve. Minus 135 is going to be 45 degrees. I'm going to do and get an answer here, 15 for x. That doesn't answer our question. Remember that they want us to find EDC. We'll use the green pen again for that over here. We need to figure out that angle. It's a little trickier than some of the last problems we've been doing. Well, here's how we're going to figure this out. The 4x, we know right away that that is going to just be 4 times 15, which is 60 degrees. Now, Work with me here as we're going to kind of go around the horn here. This angle and this angle up here are connected by the blue transversal AC, and they're on the parallel lines EA and DC. They're same side interior angles, which means they're supplemented. That makes this 120 degrees. Now that we know this is 120, these angles, so the green angle, which is my desired angle, and the 120 are also same side interior, and therefore by process of elimination, our angle is 60. For our final question in video 2, go ahead and label this again. C and D, G, and that labeling is so important. We have another isosceles question. I mentioned in the previous video what that means. BF is your base, therefore your base angles are congruent. I'll use the congruent symbol. So BF is the base, that's going to be this side right here. That means this angle and this angle are the ones that are congruent. Now we have something else. HE bisects BEF. So I'll take blue pen now. HE is this thing right here, and it's bisecting BEF. That means this angle in blue and this angle in blue are the same. And last but not least, running out of colors, 58 degrees is CBF. So let's go with CBF as right here as 58 degrees. All right, so ultimately what we're trying to look for is what HED is going to be. So that is going to be this whole combination of angles right there. That's my goal. That's what I'm trying to get to. So let's talk about what we need to do here. This red angle and this green angle are alternate interior angles. That's because they're connected by BF, by the parallel lines. So right away, I know that this has to be 58 degrees. Same thing with this red angle up top because they are equal to each other. Now, how do we figure out what the blue pen angles are here? Forget the blue highlighter for a minute. What are these two going to be? Well, they're bisected. And one other thing is the three angles in a triangle, you may know this from geometry in the past, always equal 180 degrees. Three angles in a triangle equal 180 degrees. So that blue angle, when you combine both of them together here, is essentially just going to be 180 minus 58 minus another 58. And so when I do that, we're going to end up with a grand total of 64 degrees for that whole angle. Slicing it in half is going to make then each of them 32. 32. And so once we have that, it's not letting me zoom in. There we go. Now this last piece right here, I really am out of colors here. I'll see green again. So this angle here and the two little blue ones always make a straight line. So once I know that, we're going to just take 180 and subtract 64 from it. That makes the green portion 116. So HED is the combination of one of these little blue guys and this green guy. We're essentially just going to add those two together. That's going to give me a grand total of 148 degrees. Concludes the teacher-led lessons. I'm going to have you take a moment now to pause the video, try out number 10. That triangle property I mentioned might come into play. Let's pause and hit play once you finish the problem. Okay, and here are the answers to that last question. So a couple comments I'll have before we conclude the video. I recognized right away that DBE was actually a vertical angle with NBM, and you might say, well, how did you figure that out? Remember that vertical angles are always going to be formed by two lines only, and they are the non-adjacent ones across from each other. Well, this X is actually made up of this line and this line, and so if I ignore everything but those red lines, you should see that those are vertical angles. Lastly, the 2x and this 2x end up being alternate interior angles, hence why I marked it that way. And just as I mentioned in the last question, three angles in a triangle equal 180 degrees, and so here's a triangle. I'll highlight it in blue here. That's our triangle. X, 2x, and the 6x minus 36 add up to 180. Solved, and I got 24, which just so happens to be what my angle is. That'll conclude video number 2. Go ahead and try the problems listed in the assignments below, and good luck with your work.